asked if it shouldn't be AAA. Remember, if you know two angles of a triangle are congruent to two angles of another triangle, then what must be What must be true about the third angles? Say that louder, please.
It has to be congruent as well.
That's correct. If one angle is 50 and the other one is 30, then its third angle would have to be 100. And so if another triangle had angles of 30 and 50, then its third angle would have to be 100. So to state AAA is used in some books. This book chooses not to because they can always apply the other theorem which we've already learned that said if two angles of a triangle are congruent to two angles of another triangle, then the third angles must be congruent. So these look a lot like the triangle congruent statements that we learned earlier, but they're not, okay? And so we're going to learn about them today, and then we're going to practice applying them to prove similarity, okay? In the congruent statements, we had a couple others. In similarity, we'll just use these three. Side angle side similarity, side 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 similarity, and AA similarity, okay? I'll let you copy this down, and then we'll pause to talk about it. Three ways to prove triangles are similar. AA says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. It doesn't mean they're congruent, it means they're similar. Similar means they have the same shape. Okay? Remember we learned yesterday that if two polygons are similar, that one, their angles are congruent, and what was the second one? Their sides are proportional. So these three rules aren't giving us new rules, except they're just giving us enough information to prove that triangles must be similar. So if I know that two angles are congruent in this triangle to two angles in this triangle, then that means that's enough information to say those two triangles have to be similar. Okay? They have to be similar. So if I knew this length was 3 and this length was 2, and I know this length is 4, oops, I didn't want to do that. Let me put that the way I meant to write it. If I know this is 2 and 3 and this is 4, then I can find that side. Because the two angles being congruent is enough to say the triangles have to be similar. And then because they're similar, then their sides must be proportional. So I could then say, okay, 2 is to 4 as 3 is to x. Okay? 2 is to 4 as 3 is to x. So that means 2x is equal to what? 12. And so x must be equal to 6. Well, that makes sense, doesn't it? If this side is twice as big as that one, this side here is twice as big as this side, then this side must be twice as big as this side. That's what proportional means. Okay? Any questions on that? All right. So think of these three rules as minimum criteria. If I have just this information, it's enough to say the triangles have to be similar. So in side angle side, we're saying if an angle of one triangle is congruent to an angle of another triangle, and the sides including those angles, remember including means the sides that put the angle in between them. So we're talking about this side and this side here and this side here. This angle is included between these two sides, and this angle is included between these two sides. Okay? This is tough because we want to do things like this. Are they equal? No, they're not equal. They're proportional. Okay? So we don't want to use our little congruent tick marks. So there really is no symbol to show it other than to write this statement. And this statement says that AC is to DF, that's what this says, as, we read the equal sign as AB is to DE. And so this is saying these two sides of this triangle are proportional to these two sides of this triangle, and we know the angle between those two sides are congruent, then that's enough information to say that the triangles must be similar. Okay? And the third one says if all three sides are proportional. If corresponding sides of two triangles are proportional, then the triangles are similar. Just having two sides is not enough. If I have only two sides, then I have to know the angle between them. But if I know all three sides are proportional, if I know AB is to DE as AC is to DF as BC is to EF, if I know that's true, then that's enough to say these triangles are congruent. Are similar. Sorry, misspoke. These two triangles are similar. So now what is congruent if those two triangles are similar? Angle what? You said them all, but can you name one specifically? Okay, can someone help him? He's right on. That's exactly what we're looking for. Angle A is congruent to angle D. What else is true? Angle B is congruent to angle E. And good. And angle C is congruent to angle F. Okay? Any questions on that? All right. If I took this triangle, moved it over here, I get exactly the same triangle I had before once I make it bigger, didn't I? Aren't they exactly the same triangle? I'm going to move this down here so we can look at it a little better. These angles are not changing, are they? The lines are getting longer, but the angle is the same. Okay? This one here is real obvious because this point's not moving. So as I make this bigger and smaller, you can see that that angle there is exactly the same. Well, all of them are the same. We're just taking our sticks. Remember I gave you 3 sticks to make a triangle a month ago? They actually gave you straws and said go ahead and make triangles with them, right? Okay? Some of them didn't work, right? Because some of the sides were too long or not long enough. But when it did work, it wouldn't have mattered how long the sticks I gave you as long as I made sure it was in our limits, okay? If we put extensions in between those two, we put extensions between our two angles, let me get my marker, this angle and this angle, if we put extensions in here and in here and in here that were exactly the same length, that'd be the same as making this bigger or making it smaller, okay? So it looks something like that. Excuse me. So, remember the activity we did, Eli, with the little patty paper they called it? Remember we drew triangles and we drew the angles and we drew the sides, we copied them, and then we made triangles out of them, right? We said try it with 2 sides at an angle, try it with 3 sides, try it with 3 angles. Yeah, those right there. Remember that? And the angles didn't change, did they? But we could make the triangles. If we used all 3 angles, we could make those triangles really big or really small. And the angles would still be exactly the same. Well, that's what's happening here. Okay? Once we have similar triangles, then that means those angles are never going to change anymore. They're going to be congruent to each other, no matter how big or small we make the triangle. Okay? Now, why is this important? Because similar triangles can be used to help us measure distances that we cannot walk out with a ruler and measure. We can't take our, you've seen cross country with their little roller, a little wheel on a stick, and it's got a contraption on it that helps when you're done walking, you can look down and it'll tell you exactly how many feet you've walked, or yards or miles, whatever you want to set it in. Okay? Well, sometimes it's across a lake, and here's our lake. Okay? And we can't actually walk across it. I don't think any of us have that skill. If you do, please make your presence known to me. I've been wanting to talk to you for a long time.
It's the second coming.
Okay, pause just for a second. Similar triangles are an excellent way to determine indirect measurements. We can find distances that we can't measure directly by using similar triangles. So what this surveyor did, Alyssa's dad got a little bit annoyed that Evan was sneaking across the lake in his canoe, and he wondered how far it really was, so he asked his surveyor to figure out how far it was across the lake. So he took this point here and he measured a line all the way to here, straight line. And he took this point here and he measured a straight line there. Okay? And then he made sure they intersected here where this side would be proportional to this side, and this side would be proportional to this side. And of course, since these are vertical angles, they're going to be congruent. So we've set up similar triangles using side angle side. And he set that up. So in this problem, we're not saying are the triangles similar, we're saying they are similar. In other words, we're not asking you if they are, we're telling you they are. So these triangles are similar. And since they're similar, then we can use our knowledge about similar polygons to find the missing length. So which way you want to go? Small triangle to big or big to small? You're right, it doesn't, but we have to choose a way, so tell me. Small to big, okay? So 105 to what? To x equals 125 to 950. Okay? And so 125x is going to equal 105 times 950. If I divide both sides by 125, there's a lot of 5s in there. I know at least 2 of them will cancel. But since we have calculators, we can just say, what's 105 times 950 divided 125? What is it? 798. So 798 yards across the lake. Not so bad if you got a powerboat. Maybe a little bit more questionable if we're going to swim it. I know I would drown if I had to swim almost 800 yards. I don't even float anymore. I would just be, I'd be sunk. I'd be out there in the bottom of the lake somewhere.
I seen this old lady, someone crossed Chippewa Lake. She was like 60 something.
Yeah, my reasoning for drowning has nothing to do with my age. It has all to do with the fact I can't swim that well. And I would be exhausted by the time I got 30 yards out.
But you're young.
I wish I was in a boat. I wouldn't have to worry about drowning. Okay, here we go. Listen. Remember today we're doing 1 through 19 all and then 21 to 27 odds. They're not that time consuming. Get after them. You've got almost 30 minutes.